Hello everyone, we're Team 1. Our project title is called Self-Powered Pacemaker. Those of you who were not in the presentation, our idea is very simple. What we want to do is basically convert mechanical energy into electrical energy in order to power a pacemaker. Hence, you would not need a battery ever for a pacemaker. That's our idea. So, because every 5 to 10 years, pacemakers' batteries run out, and they're usually needs to be replaced. And the surgery is very expensive, and it can bring risks to students. Patients as well. And we want to avoid that. So that's our mission statement. So right here we have a demo right here. This is a heart. It has a DC motor inside of it, which mimics the heartbeat. And whenever it vibrates, it captures these two. These two right here are called piezoelectric sensors. They're basically they're designed to convert mechanical energy into electrical and harvest it into the buck converter that we have over here inside this chip. So right now we'll show you, like, when we turn it on, the heart will vibrate. Keep an eye on this. Basically, this will show you the voltage output. So every time the heart is vibrating, every time the heart is vibrating, the voltage will go up. We have this. Just keep an eye on the numbers as well. Okay. So here we go. As you can see, the heart is vibrating.
That's the actual voltage that's stored in the output capacitor inside the chip.
And pacemakers typically require very little power just to, stay continuous. So by doing this, we have more than enough to keep power. As you can see, the bar is going.
For those of you that can't see what the voltage level is, right now we're reaching 1.2 volts. And it's still climbing.
Higher that I put the heart rate.
The maximum we've reached on this circuit is around 2.5 volts. And usually these pacemakers, they require very less power, and they're on standby mode for the most part.
Yeah.
Well, depending on patient to patient. So this system does prove the concept that vibrations that are inside your body could be harvested and used as electrical charges to charge battery. And it'll slowly to leak as the capacitors are just sitting idle. So once you turn this off, it's just going to start going back to zero. Anybody has questions?
The material that you guys use to actually generate electricity,
Yeah.
what do you call that?
It's piezoelectric.
Now, what stops that from causing any agitation within the heart monitor itself? I mean, it's a moving part. What stops that from wearing out? I mean, you putting it inside the pacemaker, or is it something outside the pacemaker that can cause agitation in the body?
No, it'll be encased inside the pacemaker itself. So the vibration will hit that titanium layer on the pacemaker, which will cause these to vibrate, and in turn, mechanical energy would turn into electrical.
Because pacemaker only require about just 1 microwatt. That's about it.
Okay.
That's the power. And the heart itself can produce about 1.5 watts of hydraulic power. So that's more than enough vibration to hit that titanium layer to hit this and capture that.
Is it today's pacemakers? Do they have any moving parts inside?
No, they don't have any.
They only have battery, and then they have their circuit. That's
Okay, so this would be a moving part inside of the pacemaker? That's my question.
Yeah, inside the unit itself. Correct.
So it'll be a moving part inside of the thing. And what keeps that,
the chest vibration.
yeah, that vibration, what does that?
The heartbeats, your movement of the muscles, your lungs, any vibration in this area would capture it.
Okay, so this moving part, I guess there's no time limit, it's not going to wear out or something like that. I mean, because right now, today's pacemaker don't have anything in it. This will have a moving part in it. What stops that from wearing out? I mean, because right now you're saying that a pacemaker can last from 5 to 10 years. It doesn't have any moving parts. You're introducing a moving part, and have you guys considered that? Would that cause any more wear and tear on the pacemaker itself?
Giving
Since
the
now we're
degrade,
introducing a moving part.
degrade figure. what was it, .02 per year?
Yeah, .05.
Yeah, we
yeah.
did some research on a piezoelectric manufacturer that made a piezoelectric fan in 1982, and it lost, I believe it was 0.05% of power over that time till now. So, I mean, even though our setup is different, we couldn't really just give you a figure of how long it's going to last because, you know, the setups are different. So it would just be more further research in our project to determine that.
No, the thing is, he says the moving part.
The-
There is no moving part coming inside.
No, it's
It's
fixed, right?
simulating.
It doesn't really move like you think.
Okay.
No, it just detects a little vibration.
It's just okay, it's just detecting vibration and.
You receive it.
Yeah, there is no gear.
Okay.
Turn it off and you can show it to him. So it's just a layer. Let's say if there's a paper, there is nothing mechanical about this. All it's doing, if I'm applying vibrations to my hand, it's just gonna move along with it.
Okay.
So there is no mechanically. It's not being mechanically moved. It's absorbing the vibrations per se.
Okay.
So
I
if
think
that's-
it's more susceptible to shock, rough shock than it will be.
Okay.
All right, you said something about how the pacemaker takes very little power to remain on standby. What about discharging? What's the voltage level of a pacemaker discharge?
voltage level is hard to say, but on let's say or power base,
Yeah.
it goes from anywhere from, depending on the use of it, it's 1 to 10 watts, but 10 microwatts. But now pacemakers are generally no more than 1 microwatt of usage. That's when it's on state.
Yeah, so it should be no problem.
Yeah.
Yeah, those should be no problem. Anybody else? All right.
All right.